And this question came in. I thought this was a really cool question. There was someone who was fairly new to the database world or the DBA world. And they said, they said it was pretty simple. They said, I create a table called T. It looks like that. And it says table created. They were doing it in SQL Developer. And then I click on the SQL tab, which actually generates the DDL for that table. And they said, I was expecting to sort of get that back. And there are preferences in SQL Developer in which you can actually do that. But they got back the create table command, followed by all of this kind of stuff that you have at the end of a create table command. And they said, can you explain all this stuff to me? Because I'm fairly new, and what do I, what do I choose for all these values? Now we get into the interesting ones, which was storage. I had the luxury of scribbling from what I showed you on the slide before. So storage came up with initial, next, min extents, max extents, percent increase, the free list, which you've already talked about, buffer pool, which I'll come back to maybe on a separate page, flash case, and cell flash case. Okay, we might come back to these. Let's talk about these ones next. First, initial, you can choose an initial size, say 10 megabytes. You could choose a next size, say 50 megabytes. These used to be important way back in the day, because back in the day, there was a ceiling on how many extents you could have. On an 8K block size, you had 505 extents, and that was it. The reason for that was, at the start of every table, we had a thing called the segment header. There was one block at the start of the table, which actually had in it where all the extents were. Extent number 1, extent number 2, etc. That's an 8K block size, and as a result, we could actually fit 505 entries in that segment header. That's why there was a limit. Way back in Oracle 7.3, we introduced the concept of a segment header being able to point to a thing called an extent block or extent map block. So the first 505 would go in there, and then number 506 would go in there, 507, etc. And thus, max extents unlimited came into being. As a result, before that, you chose a next extent such that you thought, well, I don't want to ever get too close to that. So you wanted that to be suitably big such that you never hit that ceiling. Nowadays, pretty much not an issue, because that's not an issue. Initial extent size, pretty much not an issue. The motivation for this goes back to way back in the days when we didn't have disk arrays. You actually had physical disks. And so by choosing a large initial size, you would get contiguous allocated space on the disk, which would be good for full table scans. I would challenge anyone nowadays that has a single disk for their Oracle database or Model 2 disk. Normally you've got 5,000 disks, and they're shared amongst 12 other databases with 35 other applications on some SAN that you've never seen. So initially next, pretty much no drama anymore. I would generally use what we call locally managed table spaces with system allocation, which means you'll get 64K extents to start with, then megabytes, then 8 megabytes, then 64s, and so forth. It's pretty much managed for you. As a result, you don't need min extents, you don't need max extents. Percent increase was just an abomination, a terrible thing we did, which was you could choose initial of 10, next of 50. Percent increase of, say, 50 would say, okay, next is 50. The next one after that would be 50 plus 50%, so 75 megabytes. The next one after that would be 75 plus 50%, so 120-ish, somewhere around there. So this was designed that each extent would be slightly larger than the previous one, which generally led to all sorts of fragmentation dramas and therefore, once again, waste of time. So we got buffer pool, flash, and cell flash cache. Let's talk about them, and then we'll be pretty much done with the parameters. Buffer pool. Let's put it on camera. Your options were default, keep, recycle. Early versions of Oracle. Memory was like most of us think about memory. New stuff comes in at one end. As it gets old, it gets pushed out the other end. LRU, least recently used. That was a disaster if you did a full table scan, because everything that came in full would flush out all your good data and throw it away. Early versions, we introduced a thing called small table threshold, which said, we realize that full table scans are going to cause that problem. So if you do a full table scan on a table larger than that, we'll simply add them at the end and throw them away straight away, because the likelihood of a full table scan being of benefit to you is low. So we did that. Then people said, well, that's fine, but what about tables which are full table scans, which are slightly larger than the small table threshold? What if I want to keep them? Well, you could allocate a particular section of the buffer cache called the keep pool. Similarly, if you were doing, for example, large index range scans on objects, well, they could still flush at everything because they weren't full table scans. You might want to make sure those things, those big, large index range scans didn't flush everything out. So you could put them in a dedicated area called the recycle pool. That's where those things came about. In Oracle 8.1, we introduced a much, much more intelligent thing, which we put rows, all rows come in effectively at the middle. As they age down, we actually record how many times they've been touched by applications doing queries on them. When they get to here, if they've been touched a large number of times, we promote them to the hot end. This is what we call the touch count algorithm, and it pretty much does away with the need for that. It does away with the need for that. So once again, all these buffer pool parameters, you can pretty much ignore. Dare I say, we've made that management autonomous. We've automated it. It's now managed very, very well. Literally since 8.1, I've almost never, ever seen the need to set buffer pools. Which leads me to my last two before we run out of time: flash cache and cell flash cache. Only applicable generally applicable for Exadata. The flash cache, number one, is a recognition of the fact that flash is a very, very cool technology and it's generally a bit cheaper than memory. So you've got your buffer cache here, which might be, say, 200 gigabytes, but you could, for example, have 4 terabytes of flash on a database server. As stuff gets aged out of the buffer cache, normally we would have to read it from disk again. Well, maybe we just put it into the flash cache here. So it's like a secondary buffer cache. It's slightly slower, but obviously a lot larger. That's the flash cache. You'll see it referred to as a database smart flash cache. That's a facility that can be used on Exadata and on other databases as well. Cell flash cache is a recognition of the fact that in an Exadata box, we have a database server and we have what's called a cell server, something that actually holds the disks. These are just basic compute nodes for the database. These cell servers used to come with just lots of disk as well, but now they come cranked up with a whole stack of flash on them as well. So unlike the database flash cache, which is as things get aged out, what this is as we read things from disk, we can read them into the flash cache as well and then provide them to the database server. When someone comes eventually and says, I need that data back from disk again, we can actually give it to them from flash as opposed to the flash cache. This is pretty much automated. You can control it using cell flash cache, but Exadata systems can automate that usage as well. So we've got a few minutes left. You can see we've covered %free, %use, all of these. We covered all of these. Table space users, I'll come to you in a second. I didn't get time to cover this one because we're almost out of time. So as you can see, what I'm really recommending is, for the vast majority of the time, all you really have to do, in my view, for most applications, is set %free and set the table space and maybe compression. And I think you'll be good for 99% of your applications. Most of the other things are just as I said, a trip down memory lane, a historical look at some of the things we've had that you had to manage in the past.